This is Robbie Nawrocki with my Lab 7 op-amp circuits with the Arduino. We're going to start off with exercise 1, solving for the gain from a non-inverting amplifier circuit shown at the left. V plus here is going to be equal to the V minus equal to the V in, since it's an ideal op-amp. And I'm going to be analyzing the current going into this node here, which you can see in this equation. Solving through the algebra, I get an equation for V out in terms of V in and the resistances, and as a result I can get the gain as the ratio of V out to V in, which is 1 plus R2 over R1. Next we're going to move on to exercise 2, which is the unity gain amplifier. Here we've got the unity gain amplifier. We'll look at the code real quick and give this an upload. I'll check the serial monitor just to make sure everything's working. We can change the values with the potentiometer. We'll hop over to processing, give it a run, and we'll see that as we change V in, V out will follow, except for when V in drops below the minimum voltage the op-amp can output, since it's not ideal, which is around 2 volts, and the same up here around like 4.9 volts. And V minus is always following V out since they're connected. So basically expecting V out equals V in, and you get that for the range where it's not clipped off by the op-amp. Here is the inverting amplifier circuit. Let's look at the Arduino code. The main difference here is that there's another pin as an input. We'll go ahead and upload and check the serial monitor real quick just to see that it's working. And you can see we can vary the values with the potentiometer. We'll hop over to processing, give it a run, and you can see that you are able to invert the input voltage of V in around that reference voltage of 2.5 with the gain of 10, and it clips off around 1.8 volts and 4.3 due to the non-ideal op-amp. So the op-amp isn't able to output perfectly close to the rail voltages of 0 and 5 volts. Here we have the derivation for the integrating amplifier. As you can see, we're analyzing the voltage at this node here, and you have this reference voltage of 2.5 volts. And when you go through the algebra, you end up with something in the frequency domain, and if we integrate, we're able to get that into the time domain. Now here is the circuit wired up for the integrating amplifier. The Arduino code once again, and if we go ahead and upload and open the serial monitor just to check the values, you can see we're able to change them. We'll go to processing real quick. So here's processing. So if we change V in by a little bit and drop it below the 2.5 volt line, V out will essentially integrate V in and negate it by that factor of 1 over RC. So if we go above the 2.5 volt line, you can see it'll do the opposite. And it'll clip off around 1.8 at the bottom because of the output, and then it'll do the same thing above the around like 4.3 volts. And one other thing to note is that you're able to get up a little bit higher, essentially as like an overshoot type deal with the capacitor, and then it settles back down to around that top of 4.3 volts.